work right up to the end and maybe have to guess on something, right? Where you're just going to have to fill them in. So it's really going to be important to work steadily. Now, our harder ones at the end sometimes, although a lot of people have questions on this one right off the bat, right? Number one, well, the limit problems, we haven't done. I mean, so we really do want to spend some time this week going through this first section, okay? The no calculator stuff with multiple choice, because we really haven't done a new packet. I gave you sample 3 quite a few weeks ago where we worked through sample 3. We did quite a few of them leading up to the midterms, but again, that's been a while ago. We've spent more time with the free response, and we've been using our calculators a lot more here lately too. So the calculator stuff we should be pretty good with, but the no calculator stuff we probably need a refresher on some of that, as you probably found out as you were working the last couple days last week. So 28 questions, 55 minutes. It's going to be, work, and skip some maybe if they're going to take a while. So you get, maybe there's some easier ones at the end. You want to make sure you have time and you don't leave those blank at the end and have to guess on those if you spend a lot of time on a harder. Now, if you know what to do and you just know it's going to take a while, maybe put a special mark by that so you can come back to it. But maybe go through, because there might be some easier ones at the end that don't take very long. You want to make sure you get those. So whatever your strategy is, think about that. Okay, then the next week, on that Tuesday of next week, we'll be doing the calculator multiple choice one. Now that's 17 questions and you get 50 minutes, so it's about 3 minutes per question, so it's almost the same amount of time and quite a few less questions. But you might be punching into your calculator a little bit, which sometimes takes a little longer. Probably not the same amount of time pressure on that one. Then when we get to the free response sections, they're 3 questions each. Even though the actual AP test has now reduced the calculator part to 2 questions. There's 4 that are no calculator, and there's 2 that are calculator. So basically you get 15 minutes of questions. So if you're taking the actual AP test, the section where you get to use your calculator, those 2, that's 30 minutes long. And then the 4 question section is an hour long. But for us, we're going to have 3 questions each. And so there'll be 45 minutes each time. And those, usually, it's not a time issue. Usually, you've done all you know how to do within 45 minutes. Not always. Some of you will work right up to the end. But oftentimes, people might be done in 30 to 35 minutes, whatever you've done, as much as you can do, or maybe you did it all, whatever. But so time pressure doesn't seem to be as great then. Okay? So that's what we have coming up on Friday. Of course, we do have the quiz overall chapter 7, which here in a little bit we'll review for that and give you some work time on that. I've got a worksheet with some review problems that I want to give you. Now, that's not till Wednesday, so I want to give that to you here at the end a little bit. You can work on it Sunday class. That'll be kind of your homework. You could work on it during class tomorrow a little bit, have time to ask some questions about it and that kind of stuff. So we want to do a little bit of both. We want to be reviewing for the test, Friday's test, but we also want to be reviewing for the quiz as we go along here too. Okay, that's why, if we were just focused solely on the quiz, we maybe could do it tomorrow, but I think mixing in some of both is probably good, especially with these shorter periods. So this one, I think I'd helped you on, everybody, pretty much. We said you could do L'Hopital's rule, which is the derivative at the top, derivative at the bottom. Now remember, b is just a number, so when you do the derivative, that would just disappear. So if you do the derivative at the top, that'd just be -1. If you do the derivative at the bottom, that's just x to the 1/2, so it'd be 1/2 x to the -1/2. You could flip that up to the bottom. Actually, the 1/2 could flip up, but if you're uncomfortable with that, don't worry about it. This would just be the square root of x. That could just flip up. You could leave the 1/2 there. But now you could let x approach b, and so now you get negative square root of b divided by 1/2. But now you do eventually have to flip that up, so it'd be -2 square root of b. So A, I assume, was the choice. Is that right? The other option we said is you could multiply by the conjugate, which would be root x plus root b and root x plus root b. Now remember, when you do that, you don't want to FOIL out the bottom. That's the whole point, or the top, excuse me. You want to FOIL out the bottom because it just ends up being x minus b. Up here, you don't want to FOIL this out because you want that something to cancel. So you want these to cancel. Problem is you need to factor out a -1 here first. factor out -1 to turn that into x minus b. Okay, now you plug in your b, so you get square root of b plus square root of b, which is 2 square root of b, and then of course you got the -1 out there. So either way, you get that answer. So those are limit problems. Remember, you plug in initially, hope you get something, but if you get 0 over 0, then you keep going. It's usually a factor and cancel kind of thing, or L'Hopital's rule. That's probably the better one, to be honest, most of the time. Do L'Hopital's rule. That's such a real simple canceling one. L'Hopital's rule, derivative of the top, derivative of the bottom. Was there another limit one on here while we're talking about limits? This had a little bit of limits here on number 3. Which one? 26. Because those are the, you know, there we go. That's exactly the kind I was looking for. Okay, now, remember the no calculator section, especially the multiple choice, that's where the trig, the pre-calc, logs, exponentials, knowing what certain graphs look like. We talked a lot about the absolute value graphs, right? If you're supposed to do a derivative or an integral with an absolute value, you're probably going to want to draw a picture of it, okay? And so it's a V, or it's whatever's below the x-axis just flips up to the top, that kind of thing, okay? So you need to think of it that way, because there is no rule to handle the absolute value. So in the no calculator, we see that. But you're going to have to do it log, exponentials, your trig functions, and then this idea of limits. So we just talked about L'Hopital's rule, those kind of things. But now, so you see one like this. Now, maybe you plug a 0 in right away, okay? And maybe you go through the whole thing of tangent is sine over cosine, that kind of thing, whatever. Now, I think that's way more work than you need to do, but let's say you do that. And you plug in your 0 for h, okay? So you put in a 0 here, you get tangent 2x minus tangent 2x, that's 0 over 0. So then you start thinking about L'Hopital's rule and all that. No. What are you really supposed to think of here? This is what? Definition of the derivative. This is just a derivative problem. When you see limit as h approaches 0, and you see this f of x plus h minus f of x, look, that is the definition of the derivative. That's to subtract the y's, subtract the x's. That's rise over run. That's definition of the derivative. So what this question is really asking is, what is the derivative of that? That's what this question is asking. So my hope is, and this is very, very common on this section, my hope is when you see that, as soon as you see that h approaches 0 or whatever, you don't think it's a limit problem. Now, number 1 was a limit problem. Okay, so you're probably going to have one of those. But this one is not. Okay, this is a definition of derivative. Now, there is another version of the derivative, might be good to write down, that looks like this. And if you have this, this is also. And to be honest, that first problem looked a little bit like that. But it wasn't. But it was close. This is also definition of derivative, because what you have is 2 points, a and x. You have 2 points, a and x, and the top is subtracting the y's, and the bottom is subtracting the x's. So this is slope, and then the 2 points are coming close together. X is approaching a. 1 point's approaching the other point. So this is also definition of derivative. So if they gave you a problem like this, let me show you what that would have looked like on this one. That would have been something like limit as x approaches a would have been tangent 2x minus tangent 2a all over x minus a. So if you plug a in for x, you get tangent 2a minus tangent 2a, which is 0. A minus a is 0, 0, 0. This would be also telling you to do the derivative of tangent 2x. Okay? That would also be saying do the derivative of tangent 2x. Now, this one, you actually could do L'Hopital's rule. I don't think L'Hopital's, I guess you could do L'Hopital's rule here, where with respect to h, I guess. Here you, well, no, because it's really with respect to x, so you'd still get 0 over 0. So I don't think L'Hopital's rule works on this one. This one you actually could, because think about it. Since a is just a number, when you do the L'Hopital's rule, derivative at the top, you do derivative of tangent 2x, and then the bottom would just be 1. So what would you have? You'd have the derivative of tangent 2x. So actually, if you see one like this, L'Hopital's rule would actually work. Here, you'd be doing the derivative with respect to x, so the bottom is just 0. So you're going to get 0 over 0 over and over again, and L'Hopital's rule won't work. So you really have to recognize this as doing the derivative. So the derivative is secant squared 2x, and then you got to kick out a 2. So that right there. Okay? So a couple little things that just come up, and that's kind of my hope this week is that we can kind of really refresh our memory on some of these little things that come up. The big ideas I think we're coming around to, we're doing pretty good. We're going to be doing more of that with the pre-response questions, those kind of things. So that helps you on a lot of these problems. But some of these little things we want to make sure to do. Okay, what else is something you had questions about, especially in this first section here? 16, 17, 21. Here's a good one. This is related rate. This is from back in chapter 4, and pretty common. You don't see this too often on the free response, although it's generally thrown in as one part, like you're dealing with some equation, and all of a sudden it asks how, it might be a volume problem or something, or an area in a region, and then they might ask how fast is some part of that equation changing, and it becomes a related rate problem. So it does show up there, but it really shows up a lot here. So the volume of a sphere, so they tell us this, so 4 pi r cubed over 3 is a volume, and they say the volume is 36 pi. At the instant, the volume is 36 pi. So we're going to put those two equal to each other. What's this 12 cubic feet per second? That's V prime. So we better do V prime. So let's do the derivative of this. So we bring the 3 down in front, which you cancel that 3. So we'd have 4 pi r squared r prime. Don't forget that, because you're doing the derivative with respect to time. So we're doing dr dt there. So we have to tack on an r prime. And that's going to equal 12. I'm just writing down all the different things I've got here, and then I'll see what I can do with it. Okay? How fast is the surface area increasing? So what does that mean? They want S prime. So S prime would be 8 pi r prime. So I need an r and an r prime to plug into this. Well, I think I can get those from these two equations, can I? I can solve this one here to give me an r. So I can multiply the 3 over to here. So that's 108 pi on this side, and 4 pi r cubed on this side. Divide the pi's out, divide by 4, and get 27. So r would be 3. So now I can plug a 3 in there. Now I just need an r prime. Well, let's take that 3 and put it there. Does that look good? 4 pi, 3 squared is 9. That'd be 36 pi r prime would equal 12. So divide by 36 pi, 12 over 36 pi, which would be what? 1 over 3 pi. So 1 over 3 pi would be my r prime right there. So the 3's cancel, pi's cancel, 8. Looks like what I want. Right? So we just got to remember that implicit differentiation when we're doing these related rates. We take those equations, that's V prime, S prime, we're going to multiply, that's going to tack on R primes, and we just plug numbers in. Okay? 17. Now those are not absolute value bars, those are just parentheses, square brackets, same as parentheses. Okay? If f of x is equal to this, well, I think I just substitute that. Right? I mean, I'm looking at my answers, and my answers have g, integrals with g's in it. So to me, I'm just going to take this and substitute. So this would be negative 2 to 2 of 15 minus g of x minus g of x dx, which would be 15 minus 2g of x dx, right? Now I look over here and I don't see any of that. What can I do with this? Split it. Negative 2 to 2 of 15 minus, and I can pull that 2 out because I see it's pulled out on some of these other ones. Right? So this is just a little question about our little rules for splitting up integrals. Now what's this guy here? 15 from negative 2 to 2. 15 times 4 is 60. Or you could do fundamental theorem. Antiderivative is 15x. Right bracket. Put in a 2, it'd be 30. Put in a negative 2, it'd be negative 30. 30 minus negative 30. 30 plus 30 is 60. Right? So we do it either way. Either way. So this becomes 60. So it looks like E. 60 minus 2 times the integral. Okay? So again, the multiple choice section is where they can ask you all these kind of, all these different things we learned about the rules for splitting them up and those kind of things. All right, 21. This looks like a good one because it's kind of like what we're going to have to do on our quiz Wednesday. Solid has a circular base. Cross sections mean slices. Equilateral triangle is one of those we've memorized. Square root of 3 over 4 s squared is the area of a equilateral triangle. Now it doesn't tell us, it just says a solid has a circular base. So what I would do is I would put that right at the center. Has a radius 3. Why do I need to put it on an XY axis? Why do I need to put it here? Maddie? I need an equation, right? Yeah, for my integral. I'm going to need something to go from, right? The slices are perpendicular to the x-axis. So I need the top equation minus the bottom equation. I need an equation. What's the equation of a circle with radius 3? What is it? Yeah, I mean, I could put it in y form right away, but isn't it x squared plus? Right? So y is going to be plus or minus square root of 9 minus x squared. Now, maybe if you already got that, you already know that, that's awesome, because we've dealt with it quite a bit, so we should, really, okay? I mean, that's why I need to put it on an xy axis and give it, so I can give it an equation. I mean, that's why we have the Cartesian coordinate system. That's why we have x's and y's. So we can give names. We can give a formula to these graphs, to lines and parabolas and things like that. I mean, if I want to make this a little more challenging problem, I could put that circle up here, right? Move that center up to here and do it that. Well, why would I want to do that? I mean, let's keep it simple. Let's do the simplest equation we got, right? It'd be the same solid. It'd have the same volume, right? It'd just be a more complicated equation, and it would come out the same. All right. So what is this going to be? This is going to be my strip. So coming up off of the paper here, right? Try to picture that. But coming up off of the paper, I've got equilateral triangles coming up off of here. Okay? And so I need my formula, my integral for my thing for volume is I need the area of a slice. Right? I need the area of a slice. Well, here's one slice right here. So what is S? It'd be the square root of 9 minus x squared minus the bottom, which would be negative square root of 9 minus x squared. This exact problem could be on Wednesday's quiz. This exact problem. Right? Typically, I give you the equation that creates the base. right? But there's no reason, especially in this one circle, I couldn't just give you this exact problem. Okay, so that ends up being what, 2? So we get root 3 over 4, 2 square root 9 minus x squared, squared. So root 3 over 4 times s squared, and that would go from -3 to 3. Okay? Now this is no calculator, right? So that would be the difference for ours, but it's nice because it's squared and it's square root and it all goes away. So we end up with root 3 over 4 times 4 times 9 minus x squared. Like that. Well, the 4's cancel. Okay? The root 3 I can just leave out in front. So I'd have 9 minus x squared dx. Let me change colors. So now I'm going to do my antiderivative, which would be 9x. I'm going to remember that root 3. I'll just tack that on at the end. So I got 9x minus 1/3 x cubed. And then I'm going to put in my -2 and my 2. We should have a no calculator part to that quick. It's more practice. All right, 2 times 9 is 18. Put a 2 in there. 2 cubed is 8. 18 minus 8/3. Did I do that? Oh, -3 to 3. Why did I change this? I don't know. Thank you. So let's put a 3 in there. There we go. Yep. So that'd be 27. Thank you. 27 minus 3 cubes 27 times 1/3 is 9. So 27 minus 9 is my first one, and then a minus sign. And now let's put in -3, so that'd be -27. -3 cubed is -27 times 1/3 is -9. Minus -9 would be plus 9. So you get 27 minus 9 is 18. Minus, what's that, -18? So 18 plus 18 is 36, and I can't forget the square root of 3, or else I would choose A, wouldn't I? Okay, so I can't forget that square root of 3 that I had, that I stuck out on the outside. And on the quiz on Wednesday, when you type this into your calculator and it gives you this, leave it, right? Don't go to a decimal. I mean, you can, but then you got to make sure you go 3 decimal places. Remember, once we get, now, probably not going to be an issue too much on the no calculator one this week, but next week when we get to the calculator stuff, and when it's multiple choice, it's not really an issue either because you have to match. It's more the free response we get to, and Wednesday's quiz, which is essentially free response. If you give a decimal answer, it's got to be accurate out in the 3rd decimal place. You can give more than 3, but it's got to be accurate in the 3rd. You can round or not round, doesn't matter, but okay, got to go out to 3. Let's see. Okay, one more. Anything else? And we'll have some time. We'll take a little time tomorrow. We can take a little time on Thursday. 41. And we do want to be thinking ahead. We don't have time in between each one to do a full review of stuff. Like we take this one on Friday. We're going to come back on Monday. Part of Monday is going to be going over the one from Friday, assuming everybody's taken it, hopefully. Is there anybody who's going to have an issue on Friday? Probably, I'm guessing somebody will. There's a track meet, I know, so I'm wondering. We might have some people in your class. Anyway, hopefully we can get that taken care of. We can do it on Thursday. We can do it ahead of time. Probably the best thing. But anyway, some of the time we take up going up that on Monday and then being able to talk, about the next one. So it comes kind of fast and furious. So let's go ahead, even though this is a calculator one, let's talk about it.
When's the next one?
It's going to go Wednesday, Friday of this week, Tuesday, Thursday of the next week, and then Monday of the next week after that. So Monday, Wednesday, Tuesday, Thursday, and then Monday, and then the AP test is that Wednesday of that week. And then Thursdays, then you have the rest of that week, and the next week is your last week. Okay, so it's 3 full weeks, and then partial week,
18 days.
18, counting, not counting today. Right. All right. So let's talk about this one, and then I want to get you your worksheet so we can start talking about the review. So the function, this function is a solution of which differential equation? Now this is kind of like that verify thing we talked about. Okay. A good way to do this is to really just plug in. You know, do the derivative of this, which is y prime would be what? Cosine x minus sine x, right? That would be y prime. And substitute that there, and there. So on this one, you'd have y, which is sine plus cosine, plus y prime, which is cosine minus sine. And does that equal 2 sine? Well, the sines cancel. It actually equals 2 cosine. So it didn't work there, but I can already tell it worked there because it's the same thing on the left, right? If I take y, which is this, plus y prime, which is that, it gave me 2 cosine. So that worked. This one, I would have cosine minus sine, which is y prime, minus y. I got to remember to put that in parentheses. Minus y would be sine plus cosine. So that'd be minus sine minus cosine. So cosine minus cosine would drop out. Negative sine would be negative 2 sine, which is exactly what that says. So it's 2 and 3. So remember we did those T-charts? That's kind of like doing a T-chart. I mean, you could write this off to the side, put a T there, and then just substitute in. And you're saying that the left side equals the right side. That's all you're doing. So it's very much like we did with verify. Okay, except they have 3 different ones they're asking you if it's a solution. Okay? All right. So let's shift gears here a little bit and talk about the quiz on Wednesday. Let me pull up. Now it says volume worksheet. There's an arc length, there's an area. Okay. All right. Here we go. If you want to jot down any of this, it's totally up to you. It's all in your notes. It's all in your notes already at some point. But if you want to put this, talk about this. So chapter 7, right? So section 7.1 was started with area between curves. Now there was a problem, as some of you asked me about last week on Thursday, where it talked about a parabola. Remember that one? It said x squared minus 2kx. Had a k in it. That made it a little confusing. And it talked about the area between, it talked about the area in the 4th quadrant between the curve and the x-axis. So it was talking, it would actually, the parabola ended up coming down like this. And it said that area was 36. Well, how can that area be 36? I thought that was supposed to be negative. Well, it was talking about a region bounded by the x-axis and this curve. Whenever it's worded that way, they're talking positive. That's why we do top minus bottom, and that's why we do right minus left, to make things positive, right? The whole thing of top minus bottom is you're taking a bigger y value minus a littler y value, so that's why it's a positive height. And then your dx is the width. Height times width gives you area, right? So when we do area, that's where we first learned about the strips, and we do top minus bottom, right minus left. But we don't have to do anything else to it because all we want is that area. So we're doing the height, which is the strip, times the dx, which is the width. Height times width gives you area. Now they might be sideways strips, so then you'd have your dy. You'd have your right minus left, and then your width is dy. Then we also had the formula for length of the curve, and that you just got to memorize it. Square root of 1 plus f prime squared. So if you're doing the length of the f curve from here to here, right, and that came from the distance formula, that's why it's square root of, and we finagled that, that's where that formula came from. And we were adding up little bits of distance, right, infinitely small bits of distance, but you just got to memorize that formula. So if it's the x squared curve, you do the derivative of that, which would be 2x, and that's what you plug into that formula. So you got to find out from. Okay, then we got into all our volumes, and that's going to be a big part of the quiz. Probably half the questions, half the points, maybe more than half, will come from volume questions. So we started off with our slicing, like the one we just did. Equilateral triangles is one of them you have to know. Okay. So we had 5 different types of slices. Now the first 2 come from revolving, like Emily gave us the thing right here, right? Revolving a region around an axis is going to create circular slices. Now there might be empty space, there might not. So that's the difference between a circle or a washer slice. The other ones are where you have a base, right? So those last 3, 3, 4, and 5 there are volumes on a base. And those again are slices, cross sections. Then we had shell, the shell method, and that was a alternative for revolution problems. You would never use shell in one like the one we did today in packet sample 4. That was a slicing one. And it wasn't a revolving one. Shell is only an alternative for revolving. Now, why is it an alternative? What's good about it? Why does it give us an alternative? Because, well, they're not slices, but the strips. The strips are parallel to the axis of revolution. So if I'm revolving on a vertical axis of revolution, slicing method would have to be horizontal strips because they got to be perpendicular to the axis of revolution when you're doing slices. Okay? So when you're doing shells, same thing with washers. When you're doing shells, the strips are parallel to the axis of revolution because they wrap around. So that's what gives you the alternative is you can do different direction with your strip. And so that was this formula, 2 pi ph. Remember, h is just your strip, right minus left, top minus bottom. But p was the distance from the center to the strip. So that was always like 2 minus y or x minus 3 or y minus 0 or something like that. Okay, that's what p always was. We did a bunch of those problems. Okay, I'll put this back up here a little bit. Now here's the other thing we kind of did. Now, oh, by the way, yeah, we used a different one for semicircle, didn't we? We used 1/8 pi d squared, didn't we, for diameter, because our strip was always our diameter. We had semicircles coming up off the page, so here if you had a strip here and your semicircle was coming up off of there, that strip was your diameter, so we used 1/8 pi d squared is what we had been using. Okay? All right, so anyway, we wrote it this way. It's the same information. Okay? Then in section 7.3, we went into the work problems. Don't worry about this over here. Okay? You don't have to worry about that section. The pumping liquid problems. Don't worry about it. Okay? So we did the spring problem with Hooke's law, the force equation. Okay, so we did some of those. And then we did the rope and the bucket problems. Okay, with the pounds. Okay.
And what all equations are?
Well, anything on here. I mean, you know, I don't know what you mean. Yeah, you got to know the force equation. I mean,
And then all like
in the volume. Not liquid, we're not doing. Don't worry about pumping liquid. Ignore that. What do you mean, on the other page?
yeah.
Yeah, well, shouldn't have to do much work memorizing the area of a square, right? But maybe a little there, yeah. You know, You gotta know those. If you're doing a washer, or a circle, or a square, or a equilateral triangle, or a semicircle. Yep. And then length of a curve equation, right? Shell, right? 2 pi ph, right? And all those. And then section 4 was separation of variables, solving differential equations. We worked on last week. So you've got a y prime equals xy squared situation. So we write the y prime as dy over dx. I mean, I don't expect you to write this down. You got plenty of those there. And this will be in the video, and maybe I'll save this as a PDF, put it on our website under today, under today's homework assignment. So it'll be there. You can pull it up if you want. Okay, so you got this, and I just went through. I mean, this is one of them we did in our homework, actually, I think. And then we just separate x's and y's, x on one side, y's on the other, do your antiderivative, and get the y by itself. Now, sometimes you stop with the c already in there. Here, we stopped here, but then you can multiply by 2 to get that fraction out of there. And then if you have an initial condition, you might have to go another, you got to keep going, you plug that in. Now, this one happened to have all kinds of fractions, so it took a little while, but plug the 2 in for x or 4 in for y, and I just solved to find what c was. So it might look like that. Here, I used that other version, looked like that, and then to get rid of the fractions, they all kind of end up looking like that. But sometimes you don't have to do that much work, because that was more just because of the fractions and stuff. Okay, and so we did a bunch of those in the last week, and so you can look over that stuff. Okay, so that is for the quiz. Okay, I'll go grab the worksheets here.
I know. Just before, I was like, oh shit, it was the 7.4.
I know,
forgot
right?
that we did that. Like, I forgot how to do I thought we were just like, just have fun. Woo! Because it just didn't relate to the other one. So I was like, no, they all.
This is a pretty good review here. It's got a lot of the different problems. It doesn't have a rope and bucket problem, so I'm going to go back to the homework to look over those. It's got several volume problems, got some area, got some arc length, got, like I said, a spring problem, got a separation of variables. Okay? So, work on that. And then tomorrow we'll have some time to ask questions and those kind of things for Wednesday's quiz. Probably should keep working in the sample 4 a little bit, but mostly your focus is this worksheet to review that. Okay, I'm going to go ahead and I'm going to save this as a PDF and put it up on the website. Remember, you do not have to worry about the pumping liquid situation.
I took retarding, so I didn't do that. You know, at like 30, at like 15. Yep.
Supposed to be here. Okay, fine.